All right, so for today we're going to start on working with a small piece of the section 1, specifically how to calculate and work through kinetic energy. Yesterday you worked on reading through and completing the vocab from section 1, so some of this might sound a little familiar from what you gained from yesterday's assignment. So today you're going to need a few things. You're going to need a calculator. If you need help accessing one, let me know, and I can see what I can do to help give you either a website that you can use as a calculator or an app if you're wanting something different. And then the other things you're going to need is the formula page. If you can print it out, great. If you want to snap a picture of it, if you want to save it, if you want to write the formulas out on a piece of paper so you have them handy, whatever works for you works for me. Finally, this assignment, what I'm looking for is not just answers, I'm looking for the actual note page, including the answers to the problems you work through. So in order to get credit, I need you to post basically this entire note page with your work as we work through these problems. If I talk through a slide in particular too fast, the thing that's nice about this is it's a video. You can pause it to catch up, you can rewind and re-listen, and then lastly, if there's something you're still not understanding, please reach out to me and I will gladly do my best to help you. So we've talked about 3 main topics, or we're going to, I guess, by the time we're done, have talked about 3 main topics, that being motion, forces, and energy. All 3 of these things are interconnected. And so energy is a transfer that is occurred by a force in which we have motion taking place. And so if you imagine that you're pushing a grocery cart, for example, and so you have motion, so you have speed. And so in order for that cart to move simultaneously with you, you have to apply a force to it. As you apply that force, you are transferring energy to allow it to have motion. And so we're starting to interconnect pieces that we've discussed kind of earlier on in the semester. The next thing I want you to get out of this slide is that we're introducing our last kind of brand new unit, and that's the unit that is used to measure energy, which is the joule. Okay, and so it's abbreviated as an uppercase J. So like you saw yesterday, is there are many different forms of energy out there. The main 2 that we're really going to emphasize on to start are what's called kinetic energy and potential energy. And really today we're going to zoom in and just focus on kinetic energy. So any type of object that has motion is undergoing kinetic energy. That's the main form. So if you're out walking, running, if you kick a ball, the ball has kinetic energy. If you see a bird flying by, and again, anything that's in motion or has movement is experiencing kinetic energy. There are 2 variables that decide how much kinetic energy an object possesses, and that's based upon your mass of the object and its speed. So we have a new formula that we're going to work with today, and that is kinetic energy. Let me change my font color. Let's see here. So kinetic energy is equal to 1/2 mass times your velocity squared. So just like we do with any formula, we can then assign variables to this. So kinetic energy we can abbreviate as KE. And actually what I like to do, and you'll see this on your formula sheet, is instead of 1/2, use 0.5. Or 0.5. That's a little bit easier to rule out some issues with calculator error. And so we can use 1/2 mv squared. So the one thing that gets to be very complicated, I guess, to say with the equation is you have to make sure that you plug in information in the correct spots. A lot of times when we have an equation where we're multiplying 2 things, it really didn't matter, like F equals ma, if you multiplied mass then acceleration, or acceleration times mass. But with this equation, we have more components going on, and order does matter. So velocity we've worked with. Velocity we measure in meters per second. We used mass last unit, especially like in our weight equation, and we measured that in kilograms. So when you multiply it out and factor in that squared, we get a kilogram meter squared per second squared, which is a joule. Okay, So we're going to start applying these to some examples. Like I said, there's that formula page that you have. So have those examples out, or this page here where you can see those three options. It shows you what formula you're going to use. We have a little bit, like I said, going on with these. So it's important you get a calculator out so you make sure that you're understanding how to type these in successfully. So we're going to go ahead and dive into the first example, and we're going to set up a KFPS chart. And so we have a 0.1 kilogram bird is flying at a constant speed of 8 meters per second. What is the bird's kinetic energy? So what do I know? Well, I see that we have this 0.1 kilogram. Well, now that I see that the unit is kilograms, that's the mass. And it tells me that it's flying at a speed of 8 meters per second, so that's its velocity. It asks what is its kinetic energy, so this one's working with just finding the base equation. So my F, my formula, is going to be that KE is equal to 1/2 mv squared. We're going to go ahead and start plugging in. Instead of that 1/2, we're going to change this to 0.5, like your formula sheet. So I'm going to write 0.5 times my mass of 0.1 kilogram times my velocity squared. So I'm going to change font colors, and so this particular equation, it's better to start working through these piece by piece than typing everything in. So if you think about PEMDAS and work back in your order of operations with math, the very first thing that you're going to want to simplify before you do anything else is that exponent. So 8 squared is 64. Right now I'm not going to worry about units because there's going to be a few different things going on. So I'm just going to worry about the values. I can go ahead and simplify by taking 0.5 times 0.1. When I do that, I get 0.05. So the last piece to simplify is to go ahead and multiply those out. So if I take 64 times 0.05, I get an answer of 3.2. Now, if you take a look, the problem asked what is kinetic energy. If you follow your formula handout, that is joules. Again, if you need a quick review, or if I went through something maybe a little bit too fast and you want to hear it again, pause and rewind the video. If it's not working out right, reach out to me and I will gladly help you. So let's go ahead and move on to the next example. In the next example, we're going to start working with solving for a different variable. Okay, so as we look at example 2, it says find the mass of a car. So I can go ahead and start working on setting up my KFPS chart. And it starts out by telling me right away that I am finding mass. It's traveling at a velocity of 60 meters per second north, so we can include the velocity. And it tells us that the kinetic energy is 5,040,000 joules. So when you start working through this, for the formula, if you look at the handout, it tells you that mass is equal to 2 times the kinetic energy all over your velocity squared. And so this is, again, another place where it becomes very important in terms of how do you substitute this in. As we start to substitute in, I take 2 times 5,040,000 all over my velocity squared, which is 60 meters per second squared. So what I'm going to go ahead and do is simplify each half out. And I'm going to go ahead and put my velocity in parentheses. Just the reason why that's helpful is the fact that it kind of looks like acceleration and that the unit's being squared. So it helps you to remember that you have to actually square the value versus it's not an acceleration unit. So as I start substituting through and simplifying, if you take 2 times 5,040,000, we get this value here. Again, don't worry about units at this point. And then the bottom half, we should simplify that out by squaring. So you're going to take 60 squared, which gives you 3,600. Then that leaves you with your last step, and I'm going to go ahead and kind of fall out of order here. I'm running out of room, so the S part is to solve, and that's through division. So I'm going to go ahead and divide these two out. When I did that, I got an answer of 2,800. If you take a look at your formula, and the handout, if you look at the unit here should be the kilogram. Okay, so our last example then is working with this cheetah. It starts out by describing that it has a 50 kilogram cheetah, so I know that kilograms is a mass unit. And it has a kinetic energy, so it's in motion, of 18,000 joules. It asks how fast, so it's asking for speed or our velocity. So we need a formula, so if you go ahead and look at the formula page, the velocity one has a little bit more going on. It's the square root of 2 times our kinetic energy, all divided by our mass. So then we're going to work on the plug-in step. So this is going to be 2 times 18,000 joules divided by our mass of 50 kilograms. And now I'm going to go ahead and add in that we have to take the square root of it. So you need to start simplifying it out. Before we can do the square root, we need to simplify what's inside. So you're going to take 2 times 18,000, simplify that numerator part, and so that gives us an answer of 36,000. I don't need to do anything to the bottom, so it stays 50. Mathematically, the next best step is to do the division, so take 36,000 divided by 50. That gives you an answer of 720, and then we're going to go ahead and take the square root of that. This is where math and science, we kind of differ. We're not going to go ahead and work on finding, simplifying out. We're going to just go ahead and take the actual square root of it, using our calculator, rounding it to 2 decimal places. So then that gives us an answer of 26.83. And again, the problem was asking for velocity, so that is meters per second. So here are your 3 examples to kind of follow with working with the kinetic energy equation. If you go to the doc that's posted in the classroom, there are 3 practice problems on the second page. I need you to complete those 3 practice problems and then upload your notes along with those 3 practice problems. Please reach out to me if you have any questions or concerns.